So all atoms are composed of the same subatomic particles. The only three that we're going to care about in general chemistry are protons, neutrons, and electrons. Protons and neutrons have nearly identical masses. Here are their actual masses, and it differs in the fourth significant figure. The mass of an electron is much, much smaller. So here we have a size comparison. If a proton was the size of a baseball, an electron would be the size of a grain of rice. So much, much smaller. These actual masses you might need in a calculation in a homework problem, but it's not something we memorize. Is kilogram a good unit for measuring the mass of something that's small? No. We like to have the unit be approximately the same size as what we're measuring. So kilogram doesn't work out here. And even if you go to picogram or attogram, it's still way too big. So we use a different unit called an atomic mass unit. The name isn't very creative, but it's at least very descriptive. Atomic mass units are units used for measuring atomic masses, right? Abbreviated AMU, not AMU, it's AMU. So one AMU is defined as 1/12 the mass of a carbon atom containing 6 protons and 6 neutrons. And that might sound like a sort of a weird description. This carbon has 6 protons, 6 neutrons. Those are the massive particles. So it has 12 massive particles in it. It has a mass of 12 atomic mass units. So what that means is the mass of a proton or a neutron is approximately 1 atomic mass unit. It's not exactly, because that would be too neat and tidy. The charge on the proton and the electron are equal. They're just opposite in sign. That's important to know. So if you have 1 proton and 1 electron, when they are together, their charges add up to 0. The neutron is neutral. It has no charge. So some of the stuff in this table you need to know, and some of it you don't. So I'm going to highlight what you should memorize. So a proton has a mass of 1 atomic mass unit and a charge, relative charge of +1. We can measure it in coulombs, but most of the time we don't care about that number. The neutron has essentially the same mass, approximately 1 atomic mass unit. Its charge is 0. An electron has a mass of approximately 0 atomic mass units, and its charge is -1. You should know those facts. You want to go back? I can do that. So matter is usually charge neutral because normally we'd have equal numbers of protons and electrons. But we can have an imbalance in charge, and when that happens, the imbalance is unstable and it tends to equalize quickly and often dramatically. So here we have an illustration or a photograph of lightning. Lightning, this electrical discharge, comes from an imbalance that builds up. Positive charge building up on the ground, negative charge building up in the clouds. Now, exactly how that happens, that's just another topic entirely. But it happens, and it resolves itself through lightning. Thunder is just the sound that is caused by that electrical discharge. So lightning, static electric shocks are also buildup of charge imbalance that is resolving itself.